Let's start create a connection. First, let's clean up our spines. Create attribute delete. So we should remove all our unnecessary attributes. Let's remove texture, UVY, perimeter, and beast. So we have our clean mesh. Next, let's promote our level and branch ID to the point. Let's create attribute promote. Take a primitive here, branch ID and level, not delete, and create new names p branch ID and p level. And we have our promoted attributes here on the points. Next, we need to create vectors along edges. We'll use a polyframe node. Polyframe. And then tick normal and tangent name paste n. So we have a normal vector along each edges. Great. Pack our geometry, because I will use looping. And promote level. We will use this number to isolate what we need. Create a compile block. Compile block. And create for each primitive. Enable multi-threading and use here one. Okay. Let's. So we have our branch. Then we need to isolate previous level. Let's copy this input and change for all three and create a primitive triangle. And take a level from this branch and isolate previous. Integer L equal rim 1 level 0. And if our current level not equal L minus 1, we remove everything. Remove all prims 0 and prim none and 1. Let's check. Yeah, so we have our trunk. And now let's unpack and unpack this geometry. We can make a lookup. Yeah, so we have our points here, our points here. Let's create our lookup. Create a point triangle. Point triangle. Target here and here. And let's create a float W attribute. Let's create integer con L, con BR. So in this float attribute, we will store the width of founded point. In this con L and con BR, it's a connection level and connection branch, and create a point, store a point number, and create a vector pos. So we need to make lookup from point number 0 only. So type if at ptnum equal 0, we can start a lookup. First, we will use a near points function to find a few points. Here, let's create integer pts array equal near points from 1 at p, distance 2, and points count 3. So we have array. Let's visualize it. E at pts equal pts. So which point it found? It's 5, 4, 3, 2. Let's 4, 3, and 2. So it's found three points, and now we will load each point, create the vectors from point 0 to each of them, and create a dot product to find the point we need. Let's hide. Let's create a for each loop. So we'll looping through this array, integer pt in pts. Let's load a vector p equal point. So we take a position of first point from array 1 p pt, and we need a vector, the normal vector on this point. So create a vector n. Let's the n equal point 1 and pt. So we have a position and normal vector on it. Next, we need to create a vector from point 0 to this point, and create a vector d equal normalize. So we will normalize this vector our p minus the current position of the point. And we have two vectors, and we're ready to make a dot product. Float dot equal dot between our n and d, and make a check if dot greater than 0, we need to save point number. So store point equal pt, and we save our position pos equal p, and then break our cycle. So let's see, and what we need to do next. We need to add a point. So create integer pt equal add point. So just to check if we find what we need. Add point, 0, and pause. Let's see. Yeah, so it's found exactly what we need.